Welcome to Section 8, More Programs 1. This section focuses on applying the fundamental concepts we have learned, including variables, data types, operators, and I/O functions, through practical exercises. Our first task is to read and display student details. 1. Receiving student input. We will ask the user for the student's name, age, and GPA separately. Remember the rule: input always returns a string. We must use typecasting for age, which is an integer, and GPA, which is a floating point number. If you forget the float casting for the GPA, it would prevent later operations or accurate display. 2. Displaying formatted output. We now use f-strings to present the stored information clearly. We will also apply formatting to the GPA to ensure it only shows 2 decimal places, an example requirement for academic scores. To summarize, this program applies typecasting when reading numerical input and demonstrates how to use f-strings for clear, controlled output, like setting decimal precision for the GPA. Our next lecture, 0802. Average of 3 numbers. Welcome back to our application section. Our next exercise is calculating the average of 3 numbers provided by the user. This task is for demonstrating the input reading technique combined with basic arithmetic operators. 1. Reading multiple numerical inputs. We will use a way to handle multiple numerical inputs on a single line, the combination of input, split, and map. We map the input directly to the float type to ensure accuracy, regardless of whether the user enters integers or decimals. 2. Calculating the average. The average is the sum of the numbers divided by the count of the numbers. It is crucial to use parentheses to ensure the addition is completed before the division, respecting the operator precedence rules. 3. Displaying formatted results. Since the division may result in a long float, we will use f-string formatting to display the average rounded to 2 decimal places for better readability. To summarize, this exercise applies reading multi-number input, using parentheses for correct operator precedence, and employing float formatting for clean output. Our next lecture, 0803. Area of a circle. Welcome back. Our third program in this section is calculating the area of a circle. The area formula is pi times radius squared. This exercise introduces the concept of importing external modules to access high-precision constants like pi. 1. Importing the math module. Before we can use the value of pi, we must import Python's built-in math module using the import keyword. Once imported, we can access the constant pi using the syntax math.py. 2. Getting input and calculation. We ask the user for the radius and immediately cast it to a float. Then, we apply the area formula using multiplication and the exponentiation operator. 3. Displaying formatted area. The area is likely a long decimal number. We use an f-string to display the final result, rounding it to 4 decimal places, which is standard practice for scientific calculations. To summarize, this exercise combines I/O and arithmetic with a critical new skill of using the import statement to access Python's vast library of built-in functions and constants. We just got a taste of the math module. Our next lecture, 0804. Using the math module. Welcome back. In our last lecture, we briefly introduced the math module for accessing Pi. Now, we will explore some of the powerful mathematical functions provided by this module, which may be used for engineering, scientific, and financial calculations. 1. Square root. The math sqrt function calculates the square root of a non-negative number. It always returns a float. 2. Power. While you can use the double asterisk operator for exponentiation, the math.pow function is also available. It takes 2 arguments, the base and the exponent, and also returns a float. 3. Rounding functions. The math module provides explicit ways to round numbers up or down. Math.floor returns the largest integer less than or equal to x. Math.ceil returns the smallest integer greater than or equal to x. To summarize, always remember to import the math module before using its functions. These tools provide precise and reliable methods for handling complex mathematical requirements. This concludes our section on programs. We now move to Chapter 9, Flow Control Statements, where we will learn how to make our programs smart enough to make decisions and repeat tasks. Join me in Lecture 09-01. Introduction.